Welcome to Tech Talk. McKinsey just dropped their 2025 Technology Trends Outlook, and what they found is reshaping how we think about the future of business and technology. This isn't just hype. 78% of organizations are already using AI in at least one business function, and 92% of executives are planning to invest even more over the next 3 years. Let's break down what's actually happening right now. Number 1. Agentic AI is the breakout star. You've heard about ChatGPT and AI assistants, but Agentic AI is different. These are AI systems that don't just chat with you. They act like virtual coworkers. They can plan complex tasks, use digital tools designed for humans, and actually execute work autonomously. Think about an AI agent that doesn't just tell you how to book a flight. It actually goes onto the website, fills out the forms, and completes the booking for you. OpenAI's Operator, launched in January 2025, can already do this. It handles web-based tasks like making reservations and ordering groceries. Google's Gemini can visit websites, click buttons, type queries, and extract data based on natural language prompts. The game has changed. We're moving from AI as a tool to AI as a colleague. Here's what's wild. Job postings for agentic AI roles exploded by 985% from 2023 to 2024. Companies poured $1.1 billion into agentic AI development last year. This is growing faster than any other tech trend right now. McKinsey found that when they used agentic AI to automate credit memo drafting for a bank, analyst productivity increased by 60%. That's not a small improvement. That's transformative. Number 2. Artificial intelligence overall is scaling fast, but most companies are still figuring it out. Here's the paradox. AI is everywhere, but only 1% of companies say they're fully mature in their AI deployments. The technology is racing ahead, but organizational adoption is lagging. The gap between AI's potential and actual business impact is massive. The good news? The cost of AI is plummeting. Inference costs are declining between 9 times and 900 times per year, with a median of 50 times annually. That's making AI accessible to companies that couldn't afford it before. We're also seeing an explosion of smaller, specialized AI models that can run on your phone instead of requiring massive data centers. Meta's Llama 3 models can now handle real-time language translation directly on your device, offline. Multimodal AI is the next frontier. These systems can process text, images, video, and audio all at once. OpenAI's GPT 4.1, Anthropic's Claude 4, and Google's Gemini 2.5 all released major multimodal upgrades this year. Google DeepMind's AlphaFold 3 can predict protein structures and molecular interactions, accelerating pharmaceutical development. We're not just generating text anymore, we're generating scientific breakthroughs. Number 3. Application-specific semiconductors are having a moment. AI's explosive growth created insane demand for specialized chips. Traditional CPUs can't handle AI workloads efficiently. That's why we're seeing custom chips designed specifically for AI training and inference. These chips deliver superior speed and energy efficiency for their specialized tasks. NVIDIA has dominated this space, but the landscape is shifting. Amazon, Google, Meta, and Microsoft are all building their own custom chips to reduce reliance on third-party suppliers. This isn't just about performance, it's about control, cost, and competitive advantage. Patent filings for semiconductors are accelerating faster than any other technology sector right now, reflecting how critical these chips are to everything from autonomous vehicles to AI data centers. Here's the challenge. Semiconductor manufacturing is incredibly complex and capital-intensive. Building a single advanced chip fabrication plant can cost over $20 billion. The geopolitical implications are massive. Countries are racing to secure their semiconductor supply chains because whoever controls chip production controls the future of technology. Number 4. The rise of autonomous systems is accelerating. We're seeing robots, drones, and AI agents moving from pilot projects to real-world deployment. These systems aren't just executing programmed tasks anymore. They're learning, adapting, and making decisions. Darktrace's AI agents autonomously detect and respond to cybersecurity threats in real time, modeled on the human immune system. They identify anomalies and take action without human intervention. Salesforce's Agentforce platform lets businesses deploy AI agents that autonomously resolve support tickets, schedule meetings, send follow-up emails, and qualify leads. This is digital labor at scale. The combination of agentic AI with robotics and autonomous systems is creating machines that can operate independently in both digital and physical worlds. Number 5. Scaling challenges are the real bottleneck. Everyone wants to deploy AI, but data center power constraints are becoming a major issue. Training large AI models requires massive amounts of electricity. Tech giants are collectively spending hundreds of billions of dollars on AI infrastructure. Google parent Alphabet, Amazon, Meta, and Microsoft are each projected to spend $70 billion to over $100 billion on AI-related capital expenditures in 2025 alone. This isn't just about building more data centers, it's about energy grids, cooling systems, water usage, and environmental sustainability. The physical infrastructure requirements for AI are staggering. Supply chain delays, labor shortages, and regulatory friction around grid access are slowing deployments. Scaling AI isn't just a technical problem, it's a logistical and political one. Number 6. Regional competition over technology is intensifying. Countries are racing to build sovereign AI capabilities. France, Italy, Spain, and the United Kingdom are developing domestic AI infrastructure. Vietnam is building an AI research center with NVIDIA. The Middle East, particularly the United Arab Emirates, is positioning itself through massive infrastructure projects. This push for technological self-sufficiency is reshaping global economics. Semiconductors are at the center of this competition. Whoever controls advanced chip production controls the future. That's why the United States is investing heavily in bringing semiconductor manufacturing back onshore through the CHIPS Act, which allocated $52 billion for domestic chip production. Number 7. Responsible AI is moving from principles to action. As AI gets more powerful, concerns about transparency, bias, fairness, and accountability are growing. California's AI Transparency Act, effective January 2026, requires AI companies to offer free AI detection tools and include disclosures in AI-generated content. A federal judge ruled in August 2024 that AI companies were illegally storing visual artists' works in their image generation systems, setting a precedent for copyright law as it applies to AI. Companies are implementing AI governance platforms and seeking third-party risk evaluations. The question isn't just what AI can do, but what it should do. Trust isn't optional. It's becoming a competitive advantage. Organizations that build robust guardrails around AI deployment will gain user confidence and regulatory approval faster than those that don't. Number 8. The explosion of small, specialized models is democratizing AI. For years, the narrative was that bigger models were always better. But we're seeing a shift. Smaller models, handling 10 billion parameters or fewer, are proving just as effective as massive models for specific tasks. These models require way less computing power, dramatically reducing costs and energy consumption. This is huge for accessibility. AI is now being integrated into smartphones, household appliances, trucks, and industrial equipment. You don't need a supercomputer in the cloud to run powerful AI anymore. You can have it in your pocket. This democratization is accelerating innovation. because more people and companies can experiment with AI without massive infrastructure investments. So, what does all this mean for you? If you're a business leader, the message is clear. AI adoption is no longer optional. Your competitors are already deploying these technologies, and the gap between early adopters and laggards is widening. But deployment isn't enough. You need to rewire your operating models, upskill your workforce, and build governance frameworks that ensure responsible use. If you're an individual worker, the landscape is shifting beneath your feet. AI won't necessarily replace your job, but someone using AI probably will. The winners in this new economy will be people who learn to collaborate with AI systems, not compete against them. Upskilling isn't optional, it's survival. The technology trends shaping 2025 aren't just about cool new gadgets. They're about fundamental shifts in how work gets done, how businesses compete, and how nations position themselves globally. Agentic AI, application-specific semiconductors, autonomous systems, and multimodal AI are converging to create capabilities we've never seen before. The pace of change is accelerating. Companies that move decisively from experimentation to scaled adoption, while building robust safety and governance frameworks, will capture the most value. Those that wait will find themselves playing catch-up in a game that moves faster every day. What do you think? Are we moving too fast with AI deployment, or not fast enough? Drop your thoughts in the comments. And if you found this breakdown valuable, make sure to like and subscribe to Tech Talk for more deep dives into the trends shaping our technological future. Thanks for watching.